Ever thought about the end of the universe? What does that look like? Well, the Earth's demise might give us some clues. Picture the sun, our life-giving star, slowly turning against us. Over the next 100 million years, the sun's combustion escalates. It's like Earth is a steak in a frying pan, and someone's cranking up the heat. Life will gradually fade away, larger animals threatened first, and then, in around 800 million years, even the hardiest microbes will succumb. But it's not just the heat. Carbon dioxide, that crucial gas for photosynthesis, is disappearing from our atmosphere faster than volcanoes can replenish it. Without it, plants and algae perish. Eventually, almost all carbon dioxide will be locked away in rocks, and plant life will cease. So, in 800 million years, the Earth becomes a barren, lifeless rock, with the sun as its worst enemy. But the Earth's end is just a prelude to a bigger spectacle, a galactic collision. Let's fast forward to 3,750,000,000 years from now. Our home, the Milky Way, is on a collision course with the Andromeda Galaxy. This celestial giant with its 1 trillion stars is hurtling towards us at an astonishing 200 kilometers per second. Now, before you start picturing an interstellar demolition derby, it's not quite like that. You see, galaxies are mostly empty space. So when they collide, stars, planets, and their respective solar systems don't crash into each other. Instead, they simply get reassigned to a new cosmic address. In this galactic reshuffle, our solar system is projected to end up 3 times further away from the galactic center than it is today. Our Milky Way, once a massive galaxy, becomes a mere speck in the grand scheme of the universe. And just when you thought things couldn't get any more dramatic, the universe throws a curveball. Picture this. As time continues its relentless march, something mysterious is at work in the cosmos. This enigma, known as dark energy, is accelerating the expansion of the universe. Yes, that's right. The universe isn't just expanding, it's expanding faster and faster. Now imagine peering into your telescope 100 billion years from now. You'd expect to see a sky filled with galaxies, right? Wrong. Most galaxies, except for our own, will have disappeared from view. It's not that they've ceased to exist, it's just that they've moved so far away that their light can't reach us anymore. The result? A telescope aimed beyond our own galaxy cluster would see nothing but total darkness. In 100 billion years, the once vibrant universe becomes a desolate, dark void. But what happens to the planets in this grand cosmic ballet? In the grand scheme of the universe, planets are like tiny dancers, twirling and spinning around their respective stars. Yet their dance is not always a stable one. A passing star, like a clumsy dancer, can disrupt a planet's orbit, sending it spiraling away from its star and into the vastness of space. This is because planets are relatively light compared to stars, and their orbits can be significantly affected by the gravitational pull of other celestial bodies. Scientists calculate that this cosmic game of musical chairs happens once every 30 trillion years, meaning that statistically, in 1,000,000 billion years, all planets will be homeless. They will be set adrift in the cosmic sea, far from the warmth and stability of their stars. The once majestic planets, now wanderers, lost in the cosmic abyss. Now let's fast forward to 1 trillion years. What's left of the universe? Well, it's a time so far off it's hard to fathom. It's the end game, the final act in the cosmic drama. The stars, once vibrant and full of energy, have long exhausted their fuel. The matter that once formed galaxies, stars, and planets faces a curious fate. Physicists suggest that all matter will eventually transform into one of 2 things: light or iron. Yes, you heard it right. Light or iron. The deciding factor? The humble proton, the basic building block of all atomic nuclei. If protons decay, which is yet to be definitively proven, matter will dissolve into a sea of photons, particles of light. If not, everything will eventually collapse into black dwarfs, becoming spheres of iron. The universe's grand finale, an eternal dance of light particles and iron atoms. Quite a journey, isn't it?